today.
So welcome back, and we are back with our second week of our virtual STEM Summit. And I am Audrey Russo. I'm President and CEO of the Pittsburgh Technology Council. And in a moment, I am going to introduce Marie Poloni. She's Director of Talent Attraction and STEM Development and a former teacher and our resident nerd. So you enthusiasm, and she is way smarter than I am on all topics in terms of education and science. So today we have the amazing Dr. Bailey from Allegheny Health Networks. He is going, and then tomorrow, so let me just even get you, warmed up for the rest of the week. Tomorrow we have Philips Healthcare, and in the final day, I'm very sad that this is going to be the final day, we have Rivers of Steel. We're doing amazing things around our region. So I'm thrilled to have all of you joining us today and every day to explore the world of cardiac and thoracic surgery and the role of tech in medicine. So I mentioned earlier, we have Allegheny Health Network, Dr. Stephen Bailey, System Director of Cardiac Surgery, Allegheny Health Network, Cardiovascular Institute, and Allegheny General Hospital. He is a busy man. He has taken time out from his busy day to spend time with us. So I am thrilled. Thank you so much in advance. Today, we have students and educators joining us from over 193 different educational institutions. We want to say thank you. Thank you to each and every one of you, for every educator, every administrator, and every school staff who are just continuing to do work during these just unprecedented times. And you really are our frontline workers and doing amazing work. We applaud you, we stand by your side, and hopefully today we can be additive. So at the Tech Council, let me just tell you a little bit. We work to connect the talented and curious students of our region to our membership, which is almost about 1,000 tech companies. And that includes businesses, manufacturing firms, life sciences related organizations, people working on the newest technology and the newest breakthroughs. They're all our members. They've all come together, these industries have come together to make our region an amazing place for people to live, to work, and to build these incredible companies. So these companies recognize that all of the talent that each of you students hold, and we're excited, because you are their future. You are our future. And in other words, they want us to tell all of you about some of the fun, interesting, life-changing jobs that are available right here across Southwestern Pennsylvania, otherwise known as Pittsburgh. So thanks go to Pittsburgh Community Television, PCTV. This is not only being recorded, but also simultaneously broadcast. So you pay attention if you're on the screen. So each day of the STEM Summit has been available and will be available on demand on PCTV's website, along with our own website. That's pghtech.org. Now I am going to pass the baton. I told you about our resident nerd. She is much more than that. She is our resident science and math educator who now helps us connect talent and offer STEM opportunities. You are in good hands with Marie Poloni. Thank you all for joining us today.
Thank you, Audrey. Thank you to PMI for kicking us off with that amazing opening. Thank you to all of us for joining us. As Audrey said, I'm Marie Poloni, the Director of Talent Attraction and STEM Development at PTC. And I just want to talk to you about how you can participate today. Today and each day of the STEM Summit, we want maximum participation from all of you. So if you look down at the bottom of your screen, you should see a hand and a Q&A. If you have a question, go ahead and type it in. You can raise your hand as well, but you just really need to type it in. We'll do our best to get to your question. Everything is really secure, so no one will be able to see your name or your question except for me as the host. Throughout the talk today, my student co-hosts, students just like all of you, will be asking questions of both the speaker and all of you. And when that time comes, they're going to put a question on your screen for you to answer. And so before we meet Dr. Bailey, I want to introduce you to our 3 student co-hosts today. We have Karina, we have Nathan, we have Tanner, and they're all going to be leading the show along with Dr. Bailey. They're going to start just in a minute here with a few questions for all of you, just to see exactly what you know before we get started. So let's start with Tanner.
Hello everyone, I'm Tanner and I'm a senior at the Pine Ridge High School. And the question I'm going to ask you guys is, what types of health issues will Dr. Bailey or another member of his team help you with? Is it heart arrhythmia, vascular disease, heart valve disease, heart failure, cardiovascular rehabilitation, coronary artery disease, or all of the above?
Great job, Tanner. Looks like so far, everyone is saying all of the above, which that's an amazing mind that can help with so many different conditions. We are very lucky to have him here today. All right, I'm going to end the poll and share the results. I think that's pretty easy, Tanner, huh?
Very easy. You guys are a good one. Guys are a good one.
Good job. All right, then I'm going to introduce you to Karina.
Hi, my name is Karina. I'm a sophomore at Mount Lebanon High School. And so for this question, Dr. Bailey specializes in thoracic and cardiac surgery. What does the word thoracic mean? The branch of medicine that deals with diseases and abnormalities of the heart relating to the part of the stomach nearest the esophagus. A person that suffers from heart disease or anything dealing with a section of the spinal column that begins below the cervical spine, roughly at the shoulder level, and continues downward until it reaches the lower back.
Well done, Karina. Karina, while they're answering, are you yourself interested in a career in medicine?
Yeah, I've always been interested in the sciences around postmortem sciences and looking at forensic pathology.
Oh, very cool. Very cool.
So I'm hoping at some point to be able to get into that.
So you definitely don't have a weak stomach for today.
No, I don't think so.
All right, I'm going to end that poll. We had a couple different answers there, but what is the right answer, Karina?
We have the last one, anything dealing with the section of the spinal column that begins below the cervical spine, roughly at shoulder level, and continues downward until it reaches the lower back, which most people answered.
Well done. Well done. The branch of medicine that deals with diseases and abnormalities of the heart is Dr. Bailey's other specialty that really he'll be digging into today. And then you can close out all of those. There we go. Close out all of the polling there. And then last but not least, we have Nathan. If you want to go ahead and introduce yourself, he has one last question for you to type into Q&A.
Hi guys, I'm Nathan Mamago. I'm a junior at Eden Christian Academy. And my question is, what other professionals do you think work alongside Dr. Bailey in the operating room? And as you said, you can type your response in the Q&A.
Nathan and Tanner, are you interested in a role in medicine one day?
I am. I plan to try and go into become an anesthesiologist.
Excellent.
Yeah.
I'm not sure what I'm going to do yet, but definitely this is something that has crossed my mind, and definitely I'm going to look into it further.
Well done. I love that answer too, though. You need to keep everything open, see what you're really passionate about. All right, I'll read some of these answers in Q&A. Lots of answers for nurses and anesthesiologists, RNs, physician's assistants, med tech. That's awesome. Anesthesiologist again, more nurses. Fantastic. And just so many different educational pathways to get there, so many different levels of education. Again, Dr. Bailey's going to talk about that. I think we are ready to go. So before I introduce Dr. Bailey, keep the questions coming. Dr. Bailey loves questions from all of you in the audience. Keep typing them in. Teachers, keep asking questions as well. And we'll make sure we can get those answered. Dr. Bailey, the rest is up to you.
Great. Can you guys see me? Awesome. All right. Well, it's my great pleasure to be here with the PTC, and I'm so thankful for the invitation, the opportunity. It's been a great start to the program, and I just reiterate, keep the questions coming. I think that's a great way for this to go forward. And I'd also like to say thanks because this session is really filling a void for me. In that normally at Allegheny General Hospital, we have students coming from classes around the region to watch us do surgery in real time. And that's obviously been on hold with the COVID pandemic. So we've been missing you. And this is a nice opportunity to reconnect with all the students. It's been super nice to briefly meet Tanner and Karina and Nathan this morning and the whole PTC group. And so hopefully we'll have a really good hour. I thought I'd just start by telling you a little bit about myself. I've been in Pittsburgh for about 15 years. I wasn't nearly as organized and goal oriented as the crew here this morning. When I was in high school, I had no plans to go into medicine. I was pretty sure I was going to be a professional soccer player, and that would take care of everything. And actually, I didn't think about going to medical school until my junior year in college. So I guess one message would be is if you guys don't have it all figured out yet, don't worry about it. There's plenty of time. I currently, as I said, when I finished all of my training, which I'll outline, I moved to Mount Lebanon. And like Karina, I've got a couple of kids in the high school, one who graduated from Mount Lebanon, and then one other kid in the Mellon Middle School. So we've had a great time there. As you've heard, I'm a cardiac surgeon, and that means I operate on the heart. It's pretty simple. As opposed to a cardiologist, I do mostly open operations, meaning we make incisions and can actually see things. And so I'm going to share a video with you a little bit of what's called a minimally invasive aortic valve replacement. And the field of medicine and the field of cardiac surgery is incredibly dynamic. And some of the procedures that I do now, I didn't learn how to do in my training, but they've been developed with new technology over the last 10 or 15 years. And so medicine in general and cardiovascular sciences in particular is one field of lifelong learning. So it's not like you learn everything when you start and then you practice it going forward. It's really dynamic and exciting and fun. So just quickly about my educational background. I grew up in New Jersey. I went to public high school in New Jersey. Played soccer, as I mentioned. Went to college at a small liberal arts place in Western Massachusetts, Williams College, and played soccer there. As I said, I didn't know that I wanted to be a doctor until kind of late in college, after I'd done a couple of other summer internships in business and finance, and it wasn't really floating my boat. So started late on the path and ended up working in a lab for a couple of years between college and medical school, and then did 4 years of medical school, 6 years of general surgery, where you learn to operate on the, sort of the whole body, and then 2 years of cardiac surgery. So kind of a long, drawn out training pathway. And then when I finished that, I came here to Allegheny General, where I do most of my clinical work in Allegheny Health Network. I'm going to share a video with you, but does anybody have any questions that they want to fire away now, just on what we've talked about so far?
I'll let you student co-hosts go first if you have any yet. There are some in Q&A. Are you guys good? Okay, some in Q&A. One really interesting one. Marcelo wants to know, have you been less busy during the pandemic? And if so, what do you think the impact of this will be on people's health in the near future? I think they're referring to the pandemic?
Yeah, no, great question, right? So transiently, I was as unbusy as I've been in 20 years. So for about a month in, March, April, we shut everything down. So no elective surgery, no urgent surgery, just emergent surgery. Um, because we didn't know what was coming. We saw these reports from Italy and New York where really, just absolute devastation. And I did my cardiac surgery training at Columbia University in Manhattan, where their entire hospital was filled up with COVID patients. Operating rooms were turned into ICUs. Everything was shut down. They're totally overrun. And so that, lots of models came out where we thought that was coming here. So we stopped doing everything, as really everybody did around the country. I think that was appropriate as it became more clear that we weren't going to be overrun and haven't been overrun. We slowly started the process of getting surgery going again. Honestly, there was a cost to that, in that I think we created, appropriately concerned about the coronavirus, that people for a period of time stayed away from the hospital, stayed away from the doctor's office out of fear of getting coronavirus. And we saw, a significant number of patients coming to the hospital later in the game with regards to acute illness and sicker than they otherwise would be. So we've worked to kind of to straddle the fence to make sure that patients know that if they come to the hospital, that they're safe. We've got ways of taking care of the corona patients, but also importantly, take care of all the rest of the disease that hasn't gone away. And I think we're doing a better job of that now. And at this point now, we're back to completely full swing. Very, very busy as usual.
That's a great message, though, that we have to take care of all the conditions that are existing and that you will be safe. So I'm so glad to hear that, Dr. Bailey. Your undergraduate degree, then, since you sort of changed as you were going through, what was your undergraduate degree in? That question is from Talon.
Yeah, that's a good one. So I studied economics and history at Williams. It's a liberal arts institution in Western Massachusetts, and then in my senior year, I took about 75% of the prerequisite courses for medical school. And then I worked in a lab and finished up the pre-med prerequisites in that first year after college, and then applied to med school at that point.
I appreciate that, though, that you didn't enter in as a freshman and have to do this very strict path, that you can find your way as you go and still be very successful. So that is amazing. I think you mentioned where you did your residency. You can say that again, though, if you want to, in case anyone missed it. Talon asked that as well.
Yeah, so undergrad was Williams, medical school was at Vanderbilt University in Nashville, and then I did my general surgery training out in Salt Lake City, Utah, the University of Utah. And my fellowship in cardiac surgery was at Columbia University in New York.
Okay, so again, it can take you all over. When did you decide your specialty?
Well, I guess I'm a non-committer probably. So when I went to med school, I thought I wanted to be a surgeon of some kind, and my medical school experiences sort of confirmed that. General surgery is a pathway to lots of other kinds of subspecialty surgery. So I did general surgery first. And actually, when I applied to my fellowship in cardiothoracic surgery, I thought that I wanted to basically do general surgery in the chest, like do surgical oncology, cancer resections of the lung and the esophagus. And when I went to fellowship, I just found that I was really gravitated towards the technical challenge of heart surgery and the interesting physiology of cardiovascular disease as opposed to thoracic oncology. So, I was in my late 20s and still switching direction. And ever since it's been gravy. I love what I do. I'm incredibly fortunate to be able to do what I do and have a real big impact on patients and their families in what's always a very nervous time for them, both, in terms of the technical job that I do, but also in terms, I think, in terms of how I interact with them and take care of them on a personal and a humane basis.
This will be the last question I think I'll ask for Q&A just for now,
Sure.
because it again deals with the same topic. But Malik wanted to know, what was the aha moment that you had, or did you have an aha moment that said, I'm going to switch in from business and finance and go into medicine?
So I wouldn't say there's one like just gigantic aha moment. I spent in my college, we had in Western Mass, it's really cold and miserable in January. And so we don't have normal classes during that time, but there's lots of other, experiences and opportunities that you can do. And so I had, a handful of summer internships that were, in retrospect, they were just kind of lousy internships, right? Like I was spending time in the treasurer's office of the city of Boston or in a investment bank, where it wasn't really structured in such a way to provide a good experience. So I got kind of turned off to those areas because of that. But I spent a month in Jan term of my junior year in college shadowing a general surgeon in a community hospital in Western Massachusetts. And that was just like, oh my gosh, this is so cool. And, I'm kind of late in the game, but I'm going to at least dip my toe in the water and start taking the classes and see if it's a possibility. The sciences were never like a natural draw to me prior to that experience, but it was really, transformative, and one step led to the next, and we were off to the races.
I think that speaks for all of the students on here to really look for real experiences, and really try to see, what do I like about this job? What don't I like about this job? But give it a try, because you do never know what is going to be the best fit. Before we hand it over for the video, Tanner, Karina, and Nathan, if you have anything, jump in now, or you can also wait.
Yeah, I had a question. So before Dr. Bailey mentioned a little bit about how he learned a lot of new procedures. So in like an increasingly technological world, do you think that the current information that we're learning now and the information we learned in the past, say when you were in college, will become less applicable in the future?
Great question. And no, I don't think so. I mean, I think, whatever you do, wherever you're going, a really solid foundation in the hard sciences and the liberal arts and critical thinking is critically important. And those skills that you're learning now and will learn going forward are how you adapt to changing times and changing technologies, and create the new technologies that disrupt how we do things. So yeah, no, I don't think that I couldn't disagree more that what you're learning now is going to be obsolete. It's going to be the foundation upon which everything else is built.
That's a great question, Karina. Tanner and Nathan, do you want to jump in now or wait? You're good? Okay, so before Dr. Bailey shows the video, of course, we are going to be seeing a heart surgery. So I sort of just want to give that disclaimer. It's going to look like a heart surgery. So hold on to your seats. Look away if it's going to bother you for a little bit, but take it away.
All right, so I'm going to see if I can share my screen, and again, I'll narrate. It's about a 10-minute video of a minimally invasive aortic valve replacement. And feel free to interrupt as you wish with questions if they pop up, okay? All right. All right. Can you guys see my video?
It looks good.
All right. So yes, this was filmed a couple of years ago, and it's a minimally invasive aortic valve replacement. We're just starting the procedure. If you're looking at the screen, to the right is the patient's head and to the left is the patient's feet. What's marked there is the full length of the patient's breastbone or their sternum. And we're making a partial sternotomy, opening just the top half of the sternum with two different oscillating saws. And it can be a little bit bloody here. Next step is to open the breastbone, achieve what we call hemostasis, or get the little bit of bleeding to stop, and then put in a retractor to help us expose what we need to see to do the operation. So right now we're opening the pericardium, or the fibrous sac that the heart sits in the chest, and the thing that's moving down there below the retractor is just the very tip of the heart, or the base of the heart that you can see. That's actually the right ventricle. Again, this is kind of speeded up, about a 3-hour operation condensed down into 10 minutes. So here we're putting in stitches into the aorta, and maybe I'm just going to pause for a second. I don't know if you can see my pointer, but we were putting Prolene stitches in the aorta which are going to cinch down around a cannula that we use to connect to the heart-lung machine. So in order to do heart surgery, in most cases, we stop the heart and we protect the heart with a cold solution that causes the heart to stop, but to be preserved. In order to do that, we need to put some tubes in the heart that allow us to divert blood flow from the heart, which is now stopped, so we can perfuse the rest of the body, the brain, the kidneys, the liver, etc. And so what you watched so far and for the next few frames is securing the tubes that we need to put in place to go on the heart-lung machine. Right there, that purple thing is the right atrium. That's where all the blood comes back from the body once the heart has pumped it out to bring oxygen to the body. And it comes back there before being pumped by the right ventricle to the lungs. So we've just put in the aortic cannula, which is what we're holding in the right hand there. And so that's going to bring blood from the heart-lung machine back to the patient's body once we stop the heart. So that's the aortic cannula, and we're just securing it into place here. You don't want that to fall out in the middle of the operation. A, it makes a big mess, and B, the patient would no longer be supported. So that'd be kind of a catastrophe. So we make sure that it's nicely secured, and we're just doing that now, kind of get the blood out of the way. You can see that thing that's moving there. That's the right ventricle, and we've just making a hole in the right atrium. It bleeds a little bit, but we can control it. And then we're sliding another plastic tube down into the right atrium. Again, that tube draws blood from the right atrium, and it will go from there into the heart-lung machine, which can either warm or cool the blood depending on the circumstance, and introduces oxygen to the blood so that when we pump it back to the patient without it having gone to the lungs, it will be oxygenated and the patient will be well supported. So right now we've got the arterial cannula in, the right atrial cannula in. We've gone on the heart-lung machine, and now we're placing another suture in the aorta that's going to secure one more tube that we'll use to give the solution that stops the heart and protects the heart. That's called the antegrade cardioplegia delivery catheter. There's that catheter going in now. And this operation used to be performed with about a 8 or 9 or 10-inch incision going all the way from the Adam's apple to the bottom of the breastbone. But we learned over time through using special instruments that have been developed and new technologies that we can do it through this tiny little incision. It's about 2.5 or 3 inches, and have access to do everything that we need to do through that incision. So I'm going to pause here again. This cannula here towards the top of the screen is where the solution to protect the heart goes through, the antegrade cardioplegia. And then this is a vent, so we can suck out any air that gets introduced or any blood that's filling up in the heart through this vent. Does anybody have any questions now that they want to ask, or should I keep rolling?
I have one question here from a student about the orange tubes next to the cannula.
Yeah, great question. So that is, it's basically a cinch. So I put a circular suture for each of these cannulas, the 3 cannulas and this, a suture to cinch around the cannula and to hold it in place. The suture goes through this orange tube, then we kind of cinch it down to keep it tight. So that's a really good question. So now we're just getting everything all set and ready to go. And then the next step is going to be to put a clamp on the aorta to isolate the heart from the rest of the body and allow us to give the cardioplegia to the heart. So this clamp up to the right towards the patient's head, we've completely occluded the aorta. So then the flow from this cannula is going to the body, but not to the heart. And we're giving this cardioplegia solution down this tube here to allow the heart to stop and to be protected. So at this point, we've opened the aorta, and it's a little bit hard to see, I apologize, and we're exposing the valve. Just a little bit of background on why we're doing this. So some people have a problem with the aortic valve that calcium forms and the valve becomes blocked. and it causes the heart to work extra hard and causes patients to be short of breath and to have problems like chest pain and passing out. And it's a very life-threatening problem. Left untreated, about 50% of patients will die within 2 years of the diagnosis once they start having symptoms. But it's very, very treatable. So this operation is a straightforward operation. There's very limited risk. It's not without risk, limited risk. And patients, feel better essentially immediately and very clearly live longer by having the valve fixed. So, we're getting access into the aorta. We've opened the aorta, and we'll be able to see the valve and start taking out the valve shortly. Here, I'm just putting in some sutures into the aorta to help with our exposure. And now we're actually removing these chunks of calcium. Maybe I'll try and, these chunks of calcium that are on the valve. So normally the valve down here is like tissue paper thin. It opens freely and closes easily. But with this aortic stenosis problem, it becomes very calcified and it often doesn't open or close well. And again, causes the heart to be working extra hard and to cause problems like, heart attack and sudden death. So when the valve is really bad, it often can take 15, 20, 25 minutes just to get the old valve out. And that's what we're working on here. We're carefully cutting the valve leaflets out, and we've done that now. And now we're putting in a plastic prosthesis to assess how big of a new valve we can put in. Those come in different sizes. We have a good idea before the procedure starts, what size valve we'll be putting in. But the final test is using these plastic prostheses. And the next step is to actually put in sutures all the way around the annulus of the valve, through which we'll secure the new valve. So that's what I'm doing here. And what we've done here at this point, for time's sake, is put in a bunch of durable permanent sutures all the way around the circumference of the annulus of the valve. And once we have all the sutures in, we'll pass them through the new valve and deliver it down to its appropriate space. It's really important that these sutures are kind of perfectly placed. Missing your spot by a millimeter or two can cause really significant complications, from ligating a coronary artery or causing an electrical problem with the heart, or even causing, rupture of the heart. So, obviously that's why it's like a 10-year training pathway to do this kind of work. But you get used to it over time. And so now we've got all of our sutures in a row, and it looks like it's a big, big mess there. We have ways of kind of keeping track of where the sutures are and which one's next. And we're slowly passing them through the sewing ring of this prosthetic aortic valve. So this valve is made out of a cow's pericardium. It's, again, the lining of the heart that you saw us open at the start of the video. That same lining, the pericardium, is taken from cows and prepared in such a way and sewn onto this stent to create a valve that works really well for a human. These valves don't require like long-term anticoagulation. You basically kind of put them in and forget about them, although they can wear out over time. So sometimes we need to redo this surgery or fix a re-diseased valve later down the line. So here we're kind of shoehorning the valve through the aortic opening down to the annulus where it needs to sit. Again, lots of potential problems here if you don't do this just right. If you don't get the valve down all the way, it will leak and the heart will struggle. You can also occlude the coronary arteries if you don't have it seated appropriately. So now we're cutting the sutures in the valve, making sure that we get it all the way down, and then starting to tie knots. One way in which this is different now in 2020 compared to 2015 when I made this video is that we don't usually actually hand tie these knots anymore. We can do it quicker and more efficiently by using a little technologic device, like a little grommet that slides down and secures the knots without having to tie them. So it saves about 10 minutes of time where the heart, 10 minutes less time where the heart is stopped and not being perfused. So here we're done with the main part of the operation. We've closed up the aorta. We put on some pacing wires to help stimulate the heart after the clamp comes off. The clamp has now come off and the heart is perfusing again. And just the process of the heart receiving blood flow generally allows it to wake up, if you will, and to start to beat again. We have little wires on the heart that we can use to stimulate the heart to beat if it doesn't start beating on its own. But here you can see the heart's beating again. We've taken out the cannulas at the end of the procedure. We're starting to put in some drains around the heart. So, you know, there's often a little bit of bleeding after heart surgery. So we leave some drains in to collect the blood so that it doesn't build up and cause pressure on the heart. And we slide those in. And then the final step is putting in wires in the breastbone and wrapping them together. Seems kind of barbaric maybe, but that brings the sternum together. In about 6 weeks time, that bone will be completely fused and the patient will be as good as new. You know, the last step after closing up the wires and tightening them up is just is closing the skin and soft tissue with absorbable sutures, and there we are at the end of the video. So kind of whirlwind through you know, about a 3-hour procedure in 10 minutes, but that's the kind of thing that we do every day in heart surgery. And maybe we can you know, open it back up to some questions.
I just have to say that as a virtual experience, that is by far one of the most extraordinary virtual experiences I've ever had. I mean, that was absolutely amazing. There are tons of questions here in the Q&A, but I'm going to leave it up to our student co-host first. I'm very polite.
I got a question. It's kind of more of a general question, but what has been your longest operation? How long did it take?
Oh, that's a great question and a very popular one when the students come in to visit. So, so kind of standard operations, I would say, range from, you know, 3 to 5 or 6 hours. So, you know, it depends on how much work you have to do. And one of the things that you know, one of the big parts of my job is not just doing the surgery, but sort of deciding, you know, who to operate on and what exact operation to do. You can't keep the heart stopped, you know, forever without, you know, negative consequences. So we generally try and plan operations that we can get done within 2 to 2.5 hours of ischemic time, or time during which the heart is stopped. You know, beyond that, you often run into problems with getting the heart going again and being able to support the circulation of the body after the procedure. And we do have technologies, lots of, you know, great new technologies to help the heart in those situations where we have to go longer. I'm not dodging your question. Probably the longest operation that I've done is, you know, 12 or 14 hours. And that's usually, I mean, if you're going that long, something hasn't gone very well. Like, you don't plan too many operations in this field anyway that take that long. Consistently, the longest operation that we do is fixing what's called a type A aortic dissection. That's basically like a rupture of the ascending aorta. In order to fix that, we have to do a bunch of things to kind of set up to fix it and to prepare to fix it, including cool the body temperature way down from, you know, 37 degrees to 18 degrees. That takes a long time. And then when you do that, there's often issues with coagulopathy or improper clotting after surgery because of the effects of hypothermia. So, you know, if a type A aortic dissection goes really well, it's usually like 6 or 7 hours, 5 or 6 hours. You know, if there's really complicated pathology, which requires extensive repair, you know, it can go much longer than that. And then I guess the other thing, you know, that can sometimes get into that really long range is one of the things that I do is heart transplantation. And, you know, that can be the most straightforward operation that we do from a technical standpoint. It's basically, sewing like 5 big circles. But the patients are often quite ill. The physiology is challenging. And sometimes the new hearts don't work perfectly right away. So those can be long days as well. And they usually start at midnight, so it feels even longer. But great question, Tanner.
Thank you.
Nathan, Karina, do you have anything you want to ask at this time?
Shoot,
I have one.
Yeah.
In that specific scenario, what was the main cause of all the calcium buildup for that one?
Yeah, great question. So there's 2 main reasons. Oftentimes we operate on people in their like 40s, 50s, and 60s. So we're all, you know, seems ancient to you all, but young for my patient population. Those patients usually have a problem called bicuspid aortic stenosis. So they're born with an aortic valve that has 2 or 2.5 leaflets instead of 3. Usually what happens is, you know, the aortic valve normally has 3 leaflets, and in bicuspid patients, 2 of them have kind of when the patient was born, that they were fused together. That sets up abnormal flow patterns that we don't completely understand, but leads to early calcification of the valve. So when we see somebody in their 40s or 50s or 60s with severe aortic stenosis and lots of calcium, oftentimes it's because they have a congenital anomaly called bicuspid aortic stenosis. The larger population of patients are in their 70s and 80s and 90s who have what is somewhat rudely called senile calcific aortic stenosis, or degenerative aortic stenosis. And those are patients with normal valves, free leaflet valves, but a segment of the population as they get older just have calcification form. And the older you get, the more likely you are to have it, both on the aortic valve and on the mitral valve. So it's sort of two separate populations. And we've looked for 50 years of ways to prevent the calcification from forming and also ways to get it to recede once it's formed. And we've really failed completely. So there's really no treatment for aortic stenosis other than a mechanical treatment, the valve replacement surgery that I showed you, or a really cool technology that we've been using for the last 10 years, which is called a stent valve, where we don't open the breastbone at all. We put a stent in from the leg up to the heart and push the calcified valve out of the way and leave a stent valve in place. And that's actually our first line therapy for many patients these days.
Thank you.
Sure.
I have another question as well. Is there anything you do before surgery, which I assume they could be kind of stressful since you're operating on a live patient? Is there anything you do to relax or calm down before you have your surgery, or any specific procedures you do in your head?
Yeah, so that's a great question. I'd say I had more of a pregame routine, earlier in my career, and I would say, as I said, I love what I do. I feel incredibly lucky to do it and feel like I'm making an impact every day. But it's incredibly stressful, and it was most incredibly stressful in my first couple of years in Pittsburgh. I'd spent 10 years training and all this schooling, and at the end of the day, you're never really sure if you can do it until you're ultimately responsible. So I had done all the operations, but until I came here, in my early 30s and was an attending physician for the first time, it was all in the context of having support and help from other people. And so that was really the most challenging part of the whole pathway. And if I could pick one, 2-year period that I didn't have to do again, it wouldn't be my intern year when you're getting work to the bone. It would be not doing those first couple years in practice where just, you're just worried every phone call is some disaster on the other end of the line. But you get better at sort of compartmentalizing and dealing with the stress and whatnot. And so it was a long-winded way of saying, I think very carefully and review every patient, usually the night before and right before the procedure, depending on the specific procedure that we're doing. I mean, some are things that I only do, that are really rare problems that we only do, infrequently, and some that I do every week. And, so they require different levels of focused preparation. But, might do 5 aortic valve replacements in a week, and the anatomy and the challenges on every one are often subtly different. And so you just have to be prepared to be thinking on the fly and reacting to things as they come up. One of the things about heart surgery, people who tried to dissuade me from doing heart surgery, often say, when you're a heart surgeon, you never really know when your day is done. And that's really true to a certain extent. But, it's a challenge and it's incredibly rewarding.
Such great questions. I have some over here, probably about 10. I'll try to ramp them off as best I can.
Sure.
Going back to the surgery, there were questions throughout there. One was about the solution that went in to protect the heart and ultimately, I believe, stopped the heart.
Yep.
What was the role that solution played, and to protect the heart from what exactly? That's from Dennis.
That's a great question, and forgive me for jumping through that. So, so the heart, like the rest of the body, requires blood flow and oxygen and nutrients to survive and to thrive. And when we stop the heart to work on it, we're stopping all blood flow to it. And if you just stopped all blood flow to it without doing anything to protect it, it would cause a massive heart attack, and within 5 or 8 minutes it would never start again. So we infuse a solution that's very high in potassium and is very cold. So the heart is cooled down to about 4 degrees Celsius. So its metabolic needs are vastly diminished, and it's arrested by using a high potassium solution in diastole. So very in a very low energy state, and so we use a special solution that has other nutrients and amino acids called Delnito's Cardioplegia, which has been another great sort of technological advance. Up until maybe 7 or 8 years ago, we would have to give the protective solution every 10 or 15 minutes to protect the heart. And this new solution, it's actually not that new, but this new application of an old solution gives us a much longer period of time where we can keep the heart ischemic or without blood flow. So in that operation, the heart was stopped for about an hour. I just gave 1 dose of Cardioplegia at the start, and I was good for the whole operation, which allows things to move along more quickly and more efficiently. And we can get anywhere from an hour to an hour and a half out of that 1 dose of Cardioplegia or cardiac protectant.
Wow. This is from Mark, what concern is there for the calcium bits breaking off and falling into the vessel, the aorta, or back into the left ventricle while removing the large parts?
Yeah, so that's such a great question. It's a huge concern, right? And it's a tremendous focus of any way that we're fixing aortic stenosis. So we're very meticulously, keeping tabs on all the calcium. We have little suction devices to suck up any that falls away from our immediate field. And the end result of calcium that escapes our attention is potential catastrophe, risk of stroke or risk of damage to the kidneys or to peripheral vessels. Thankfully those complications are very low, but it's a remarkably kind of low tech solution. Like basically don't lose track of the calcium and make sure you get it all out of the heart. With this other procedure called the TAVR, or transcatheter aortic valve replacement, in patients who are at high risk for that calcium breaking off and high risk for stroke, there's actually a device that we can place in the arteries to the brain, like a net, that can catch calcium that breaks off and goes to the brain. And it's a relatively newer device, just introduced in the past couple of years, that we use in selected high risk patients. Great question.
These are fantastic questions. Not a funny one, but an interesting one from Dennis. Do the wires that end up bringing that breastbone back together ever set off metal detectors or show up on x-rays?
So no and yes. They don't set off metal detectors, so no problems going through the airport. And you can very clearly see them on plain x-rays. Yeah, for sure. And they stay forever. Like they don't need to come out. Every once in a while, it might cause someone pain, but generally we leave them in and they can stay forever until they need another operation, in which case we take them out.
And I think you did refer to a gadget, but 2 questions, one from Marcella and one from Anthony, both asking about any robotic devices that you use during any of your surgeries.
Yeah, so great questions. We use a robot to assist with a couple of specific cardiac operations. It is, the robot is particularly helpful in a procedure called a mitral valve repair. And one of my partners, Walt McGregor, is an absolute national expert in that procedure and the use of the robot to help with that procedure. So the interesting thing is it's an important combination of human skill and robotic technology to make the overall process better. The robot won't make you a better mitral valve surgeon. You need to be an expert mitral valve surgeon in order to successfully employ the robot to help with the procedure. But the two together really add tremendous value. The robot allows a smaller incision. The surgeon is actually not sitting right at the patient bedside, but at a console away from the bed. And there's increased dexterity and visualization through a really small incision in a really small space. So I'd say that's the main area of cardiac surgery that we use the robot. It's also used very extensively in thoracic surgery. So for like lung resections for cancer or esophageal resections for cancer or benign disease. And it's something that continues to find additional utility really throughout surgery fields of all kinds.
And because of time, I'll just end with this last question. And you spoke a little bit about it to Karina already, but just overall, Josh was asking about just your ability to gain the confidence that you're able to perform these procedures. How did you gain the confidence to operate when there is no margin for error? How did you practice for this? And I just thought this might be a nice way for you to just talk to the students about, persevering through that and gaining confidence for whatever they might do. But any advice you have there?
Yeah, no, that's a great question. I mean, there's no other way to say it, but it's really hard, right? I mean, thankfully, you don't go right from med school and start trying to do, open heart surgery. There's a process. It's like the first operation I ever did was, I think, was a inguinal hernia or a breast biopsy, and you start by doing small pieces of the operations, and in the setting of being assisted by somebody who's very capable. And one of the things I love about my job now is I help with the development and education of training of the next generation of surgeons and heart surgeons. So it's very much a stepwise process, but yeah, it's a very insightful question, because even now, I mean, 15 years into practice, there are certain situations that without question get my heart rate up, more than others, and being able to deal with that, and whether it's compartmentalize or be able to function in stressful situations is incredibly important, and you get better at it as time goes along. In terms of advice, one of the things I share with the students that come in and visit with us is, say, what advice do you have, or what's the best pathway here? And I think there's some important components, like, first off, you don't have to be a heart surgeon and spend 10 years of post-medical school training to be an important part of the team, right? I think I mentioned, right next to me, you couldn't see it in the video because of the honed in view, but right next to me is a high school grad with technical school training who's a scrub tech who is critically important to the overall process. And there's everything in between, from PAs to nurses, to nurse practitioners, to anesthesiologists, perfusionists. It's a whole team that gets this done. I find medicine in general and cardiovascular medicine in particular to be incredibly, gratifying. And whatever area you're going into, whether it's medicine or some other field, I think the principles that I mentioned are key. You have to be smart. You don't have to be the smartest guy in the room. There's a basic level of intelligence that's critical. Much more important than sheer brilliance is work ethic. You have to work hard. There's nothing about medicine, nothing about surgery that sheer brilliance can get you around the hard work that's required. And then the third thing is you have to care, right? You have to care about the job you do, care about the patients you're taking care of, and that trifecta, be smart, work hard, care. It's a good combination and take you a long way.
Dr. Bailey, this has been absolutely extraordinary. I could stay on for so much longer. I cannot thank you enough for taking such a long time out of your busy day to do this for us and do it just so well. So thank you. I'm going to turn it over to Audrey to wrap us up, but I can't thank you enough. And thank you, students, as well. You three were amazing. Happy to have you.
Thanks, guys. It's really been a pleasure.
It was great. Thank you, Dr. Bailey. Thank you to the students for these great questions, just great questions. Your work is remarkable. I took a couple of notes that when I was just listening and thinking about all that you were showing. First of all, I did get a moment of queasiness as you first did your first entree into the heart area. That was a little bit much. I had to turn my head and flinch, but once I got past that, totally, I was all in.
Sorry.
So it's all good. But here's a couple of things in terms of the takeaways that I heard from you, and is confidence, but you made a lot of mistakes and different steps along the way. So, I so appreciate your candor. The quest for perfection and the is really just a quest, right? And that there is an art to the science, and that people shouldn't be intimidated and afraid of that. I appreciated your candor in just telling us about who you are as a doctor overall, the person, and the things that drive you, and the things that you really care about. And the whole point of that, you don't really need to be like the most brilliant in terms of intellectual quotient, but you really need to embrace the sciences and hard work. And then you can really get anywhere. And then of course that the team consists of people who have all different journeys. The other piece that I think is really important for all students to really embrace, and it's helped me in my own career, is have a lot of internships, a lot. And you heard that with Dr. Bailey. He did a lot of different things, even though he tried to cram it in his last year of undergraduate school. I was trying to imagine you taking 75% of your pre-med classes in your last year, but we didn't go down that. So there is no straight path. There is no straight path. And I think that's really important for all of you as you think about all these different options. And as he said, he chose a path that took really long training. That's not the case for everyone. And that doesn't mean that you won't have an impact. It makes me wish that I had gone to medical school. You're very inspiring. And I love the fact that you help lift others. And that's part of the joy of helping others along the way. The technology changes each and every day. Within 5 years, who knows what kinds of solutions that we'll have. So again, that was just my takeaways from listening to you and watching. And I'm very proud that you've made Pittsburgh your home and that people have access to you, and that you're solving some really, really big problems. And I'm glad you're busy again. You probably weren't, who knows during those first couple of months of COVID, it's probably good that you got back to work. So I want to thank you, Dr. Bailey, for the work that you do. I want to thank the students. Oh my gosh, just great, great questions. Thank you to our co-hosts. And I want to shout out to our sponsors who believe in us each and every day doing this work, which is Philips Healthcare, Shell Games, and Huntington Bank. And we're going to be back tomorrow. Okay, we have 3 more days, and we're going to be back tomorrow with Philips Healthcare and the work that they've done during COVID to actually save lives as well with their medical devices and the strategies that they've had. Thank you, AHN. Thank you, Dr. Bailey again. Thank you to PCTV. Thank you, Marie Poloni. And thank you to all the students and teachers and educators for Against All Odds. You are doing miraculous things these days. Signing off.
Thanks.